Lesson 6.3, Rotations. The objective of this lesson is to learn how to transform figures using rotations. This is the last of the three congruent transformations: reflections, dilations, and now rotations. A rotation is a transformation in which a figure rotates around a point to a new position. And the only point that we will rotate around is going to be the origin. So we have some rotation rules. So notice here that our first rule is a 180-degree rotation. If you rotate 180 degrees, it doesn't matter the direction, it's going to end up in the same place. And for this, the x-coordinate changes its sign and the y-coordinate changes its sign. It's the same as a reflection across the x-axis and a reflection across the y-axis. So that would actually be a combination of transformations, but it's the same thing as a 180-degree rotation. Then a 90-degree rotation could either be clockwise or counterclockwise. Notice in both of these 90-degree rotations that y and x are inverted, that we write y before x. If it's 90 degrees clockwise, that's the direction of a clock, you think that's what would normally happen, then the x changes its sign. If it's 90 degrees counterclockwise, that's opposite of how a clock turns around, how the hands on a clock move, it's the opposite direction, the y-axis changes its signs. And you will just have to memorize these rules. So keep in mind, if it's a 90-degree rotation, the x and y swap. If it's clockwise, the x changes sign, and counterclockwise, the y changes sign. Example 1, we're going to graph the rotation of triangle ABC 180 degrees around the origin. So I'm going to start by noticing that I am doing a 180-degree rotation. And so I've got my rule from the chart above. So I'm going to use the rule. I've got points A, B, C. A is at 2, 5. B is at 4, 1. And C is at 2, 1. And then I'm going to find out what it transforms to after a 180-degree rotation. So notice that A prime is the result of changing the sign for x and the sign for y. So I go from positive 2 to negative 2, positive 5 to negative 5. To get B prime, I'm going to change positive 4 to negative 4, positive 1 to negative 1. And for C prime, I'm going to change positive 2 to negative 2, positive 1 to negative 1. And so I've got the ordered pairs. Now I need to actually graph them. A prime is negative 2, negative 5. B prime is negative 4, negative 1. And C prime is negative 2, negative 1. So now we have triangle A prime, B prime, C prime. Notice that it is upside down and backwards. This is the result of only the signs changing, and it's the same as a reflection across the x-axis combined with the reflection across the y-axis. But we have now graphed the rotation and we're finished with this problem. Example 2, we're going to graph the rotation of triangle ABC 90 degrees counterclockwise around the origin. So we'll use the rule from the chart above. Notice up here that we look at 90 degrees clockwise, 90 degrees counterclockwise, and we have this rule where we write the y-coordinate with the opposite sign first, then the x-coordinate, and that's what we have here. And we just go through and mark what our ordered pairs are, and then we'll perform that rule to find out what the new ordered pairs will be. So our original ordered pairs, the pre-images, would be that A is at 3, negative 2. B is at 3, negative 5. C is negative 2, negative 5. So we'll get A prime, B prime, and C prime. And as some transformations are easier to do the x-coordinate by itself first and then the y-coordinate by itself. So I'm going to start by writing what my new x-coordinate is, which it is the opposite sign of the original y-coordinate. So my original y was negative 2. Now my x is positive 2. My original y was negative 5. Now my x is positive 5. My original y was negative 5. Now my new x is positive 5. Now to get x, or to get the new y-coordinate, I go back to the original x. My original x was 3. My new y is 3. My original x was 3. My new y is 3. My original x was negative 2. My new y is negative 2. And so I've got my ordered pairs. I'm going to graph them. A prime is now 2, 3. B prime is 5, 3. And C prime is 5, negative 2. I'm going to move my A prime over, just the label, and then I connect my points. These are the vertices of the triangle. And I see that I have an identical triangle. It has turned, so I'm going to notice this. Notice the triangle is identical, but now it's on its side. A 90-degree rotation will turn an object on its side. Now it's your turn. On the back of your sheet, use your rules and write the original ordered pairs to graph each transformation. So you'll start with the rule, write the ordered pairs, use the rule to get your new ordered pairs, and then plot those points to graph. Specifically, try problems 1, 2, 3, and 7. Pause the video here, try them out, and then you can resume and check your answers. Problem number 1 was 90 degrees clockwise. Notice that after the rotation that it's on its side and that the original went from quadrant 1 to quadrant 4. So it rotated the direction of a clock, clockwise. 90 degrees meant it moved one quadrant. Number 2 was rotated 180 degrees. Notice that it is 2 quadrants over, no matter if you went clockwise or counterclockwise. It's still wound up in the same quadrant. It's the opposite quadrant. And the figure is upside down and backwards. Number 3 was a 90-degree counterclockwise rotation. Notice that the original going to the image, that it's turned on its side, and also that it rotated 90 degrees counterclockwise. It's opposite of a clock, and it moved one quadrant over. Now number 7, I'll go ahead and note that S prime and T prime were swapped. So there was a typo in here. There was an error. However, we're going to go ahead and work through this. X, Y, we want to see what changed going to the image. So let's first look at what happened to get these values for X. We notice that it appears that Y, the original Y, became X and it changed signs. So we've got that it was the original Y and it changed its sign. And now to get Y, we take the original X and we just copy it over. So the transformation was xy goes to negative yx, and that is a 90-degree counterclockwise rotation.